So hi, I'm Randy Levensalor with CableLabs. I'm a lead architect looking at all the software aspects of NFV and SDN. We're really focusing quite a bit on the edge and access networks. Today I'm going to kind of go a little more into detail around what are the differences and similarities between OpenStack and Kubernetes. We hear those terms thrown around quite a bit, and cloud native versus like traditional lift and shift. So, for it's a little useful just to kind of dig into this a little bit. I'll talk a little bit about it and what CableLabs is doing in this space. Where is the edge? It's kind of everywhere, access network towards the customer premise and on the customer premise. Right, we see a lot of use cases. Who's just covered quite a few of them, so I won't repeat a lot of that, but we do have a lot of different access networks, different transport networks with 5G, Wi-Fi, all the new DOCSIS standards with being able to bring a lot of high-speed, low-latency networking to the home. The access net edge clouds, this is where we're going to focus a bit of time today on, is where we can actually start hosting these either in the head end or in a node or on the customer premise. Core regional data centers, these are more central, a little more efficient to run. They're larger, and you don't necessarily have to worry about optimizing as much as you do on the edge. When you're closer to the customer premise, you typically have less power, less space, less cooling, less people there all the time. So there are some other things you need to take into account when you start looking at the running compute very close to the customer premise. Again, hyperscale clouds, if latency doesn't matter, or latency doesn't matter that much, or throughput isn't your biggest concern, great. Lots of people will host stuff for you, great services and everything else on top of it. Just kind of looking a little bit, why are we looking close? Latency, throughput, those are great when we start getting close to the access or the edge of the network. The further out we move, the less expensive it is to run things, but it's also more expensive to move data. Could you imagine if all of the Netflix streaming wasn't actually cached close to the customer premise? I mean, they'll just go from 15% of the network to even more and just take down everything. So there are lots of use cases where we really do need this edge and this access platform, and we'd like to open it up for more innovation because we have these data centers and head ends and central offices there. We're actually able to clear them out, especially in the cable plant, as we push more of the cable access network stuff closer to the premise. More of the management stuff can be pushed further up towards regional data centers. And now we kind of have this nice sweet spot, and we want to start doing more with it. So I'm going to talk through a couple sample applications here. I've tried to group these. Again, we can go on and on about examples, but really on customer premise, there's some service things like the virtual CPE and actually making that simpler and centralizing it. For instance, if you want to do Wi-Fi password management, it's actually a lot easier if you could host that in a cloud, and then when you have a problem, you don't have to have the support person say, now go find your cable modem, flip it upside down with a flashlight, and go find this number and reset it. But if that's actually hosted in the cloud, the representative you're talking to can say, all right, great, this is your password, or I've reset your Wi-Fi access point. And you can give that next level of maturity or progress, or you can even have someone else support you on that remotely. Kind of moving to core and regional data centers. This is where kind of all voice, IMS, CDN features live. Though a lot of these, for some use cases, may make sense to move them all the way to the customer premise. And hyperscale, these are things again like session border controllers, a lot of the streaming video, live streaming video. These can all be centrally located, and you don't necessarily need those right on the customer premise. So, always think of where does it make the most sense to run your workload, and try to find the most economic and useful place to run it. So, again, for performance and optimization, a lot of times we're going to be looking at things at gray box solutions, not just pure white boxes. A lot of the applications we do with the cable access and with DOCSIS is encryption. And it turns out, CPUs can do encryption quite effectively, but if you have a dedicated card or an FPGA, you can actually do encryption much faster with lower power and a smaller footprint. So we're still going to see some of this, especially as we really want to optimize these platforms at the edge with these great box solutions where we do use some sort of hardware acceleration. But we do want that standard, we want that accessible, and we want that easily reproducible. Is there anything else on here? No? So I'm talking a little faster this afternoon. Too much coffee at the break. So let's talk a little bit about kind of, I had a great example earlier of a colleague from Liberty Global talking through, the different layers and different portions of the etcNFV stack. And we're just looking at down there at the bottom. How do we actually expose those VMs? And so for virtualization, I tend to have a bent towards open source. It doesn't mean you can't implement these same APIs and features with a purpose-built or a proprietary software solution. It's just kind of for us, and for doing references, we try to use open source because it eases collaboration and just makes it much easier to share, extend, and validate what's going on. If I have a problem with KVM, I can go in and look at the code and figure out what is it really doing. So KVM is, the hypervisor. It helps virtualize the VMs, and it uses hardware acceleration to do that. Takes advantage of specific hardware in the CPU. And you see kind of the typical models. You'll typically have a guest OS, a VM, running on a physical server, and then on top of that, you'll install your application. But the other way you can do it is you actually can run a container inside your VM. And this actually provides a lot of flexibility. You can scale up and scale down your VMs and do your lifecycle management of your VMs through something like OpenStack. And then with the containers running on top of the VMs, you suddenly have a much easier way to manage your applications. So you can have a Kubernetes pod running inside a VM, and then that VM could migrate if you need to, or you can spin up more and more VMs. You have that extra isolation with VMs. There's very strict hardware level isolation between VMs on the server, so it's secure. It's been around for quite a while. KVM in the cloud is a relatively mature technology. It still has some opportunities to mature a little more, but it's fairly stable. So that's kind of that's what we've started with. A lot of the initial telco clouds have come out with using KVM or a hypervisor-based virtualization for their VNF deployments. OpenStack is, again, how do you manage all of these clouds? You want to have a set of APIs, a set of open APIs that are well-defined to spin up, spin down VMs, do this lifecycle management, do things like metrics, monitoring, mapping the hardware, because you don't want to actually be placing every individual VM yourself by going in, logging into a server and starting up the VM. You really want that to be handled by the high-level orchestrator and then transfer that all the way down to lower levels in the stack. OpenStack over the last couple releases really has stabilized their APIs. We're seeing a lot more maturity in the OpenStack releases. We have 70,000 individuals, users and contributors across OpenStack. And even looking at the OpenStack community now, it's much more focused on how people are using it and not how people are going to make it better. So it's a really good, solid solution. However, there are quite a few components required to keep it up and running. It can be complex to debug. It does have a moderate amount of overhead when running it, and things like the RabbitMQ that's used to distribute the current state across the system do have some scaling and performance problems. They're a lot better than they used to be, and there's some techniques around the way you divide your resources to work around it. But again, there are those challenges there, which is why it's not necessarily the golden solution. So what are we doing at CableLabs? We're really trying to drive interoperability at this layer with OpenStack. So we have our own installer, which is a wrapper around the upstream OpenStack installer. And we actually leverage Cola containers in OpenStack. So this is a Dockerized version of the OpenStack control plane. So we're actually running containers to manage the vSwitch and to manage the VMs. And this actually allows us to greatly reduce the overhead on the systems, and it makes it much easier to roll out updates and more reliable to do the installs. Before, when you'd install all the components on the physical server, I run the script, and then I'd go home, and the next day I'd rerun the same script, and I get different results. Now that we're able to check this into specific containers and version those, it's much more reliable, and when I run it, and I run it again the next day, I get the same results, which shouldn't be a surprise, but if you've been running OpenStack for a while, you'll learn that surprises do happen. Some of these core services that we're focusing on now are, a lot of them around networking and network performance, like Open vSwitch with DBDK, and looking at different databases and storage and Ceilometer for doing the metrics. So we kind of talked about VMs and how you can run containers in VMs. Now let's transition to looking at Docker containers. Again, Docker containers can be run on bare metal. Typically use runc or another runtime library to manage it. And they can also run in a VM, like we said earlier. So that could be KVM on the right with Docker. Docker is not the only container solution out there. It's just the most popular one. Another one that's kind of in between containers and VMs are Kata containers or clear containers. And those provide a lot of the isolation that you get with VMs, with a lot of the flexibility of containers. But it's a little heavier weight than a Docker container. And there's some other container runtimes that we're actually starting to look at that are a little lighter weight than Docker, just because for a lot of the NFV components, we're just processing network traffic. We don't necessarily need all of the remaining components. So we, again, want to trim that down as much as we can, the closer to the edge, or especially on customer premise. But you can see kind of there's a few less layers in this diagram as there were compared to kind of our VM diagram. So it's, like I said, just by the nature of the way containers work, it's a little less overhead. You have a single system clock. You don't have a separate system clock for each VM. I think Kubernetes is somewhat analogous to OpenStack, where Kubernetes is how you're going to manage all of your containers, scale them up, scale them down. It's not quite a one-for-one replacement because Kubernetes actually does things like upgrades, and there's things called Helm charts, if you're not familiar with, which is a packaging system on top of Kubernetes to manage a lot of these lifecycle components, where you can kind of roll out new versions, switch over, scale up, and scale down. And typically with Kubernetes, you manage pods of containers. So these are containers that would all be on the same system. And these typically, each container will do one function and one function alone. So, a lot of times you'll see talking about, we can do 10x the number of containers on a system to a VM. Part of the reason why you can do that is that container is only doing one thing, and the VM may be doing 5 or 10 things. So just, when you hear those numbers, they do have data backing them up. However, it's not necessarily an apples to apples comparison. And with containers, you can run Kubernetes on bare metal or within an OpenStack or other virtual environment. We're seeing, especially with a lot of the access virtualization and virtualizing the head end, that running Kubernetes on bare metal is a very attractive solution, especially because most of our cable operators don't have that provisioned at the edge yet. Many of our operators do have OpenStack or another cloud-based solution deployed in regional data centers, just not at the edge. So we think that this is a way to reduce overhead, so that way you can actually squeeze more into the head end, reduce your power utilization, reduce the complexity when it comes to troubleshooting, and be able to use the same set of APIs whether you're managing the application on bare metal in the edge, in a hyperscale cloud, or on the customer premise, because the containers are lightweight enough you can run them on pretty much any hardware. Even little Raspberry Pis. You can also do VMs on Raspberry Pis, but I don't recommend it. So again, what are we doing? We have our open source reference implementation. It's a certified Kubernetes installer. And again, we take the upstream components of Kubernetes, some of the specific CNIs, so the container networking interfaces out there, and a lot of the choices that we need to make for NFV. Things like CPU pinning, large pages, and a lot of these optimizations, and we try to capture these all into this reference installer. So this way we can hopefully accelerate collaboration, accelerating defining what capabilities do we need and comparing them. And then when you go to production, there are people that will support our Snaps version in production, or you can go and look at one of the other production versions of Kubernetes, or if you're a large carrier, you can roll your own support for that. It's very easy to do the management of Kubernetes. And going from one release to the next is very easy. Kubernetes has about 4 releases a year, or OpenStack does 2 releases a year. And for us, going from our first to our second Kubernetes release took a couple weeks. Or with OpenStack, we typically have to wait a month or two after the release is finished, before enough of the bugs are fixed and all those have been rolled into the COLA packages for us to actually release the new version. So again, just kind of some hands-on experience, what does it take to, even in a lab environment, go from one version to the next. With Kubernetes, it's super simple, and they're actually focusing on constraining the core even more and locking down the core of Kubernetes and the APIs. However, since Kubernetes is a newer technology, we do see a lot more churn between releases. So a lot of times you may have to, you may be able to upgrade very easily, but you may also have to go in and change your pod file configuration files for using that. So that's one of the downsides of Kubernetes, though we expect it to mature a little faster than OpenStack has, just because if you go out and meet the Kubernetes community, there's a lot of people that were formerly or currently on the OpenStack community. So there's a lot of that learning and that DevOps has actually been adopted in Kubernetes. So we expect to see that mature fairly quickly. So all of our stuff's on GitHub. We do have a Snaps.oo, which is a test tool that libraries that we've donated to OPNFV, and that's actually the foundation for a lot of the OPNFV functional testing, as well as their compliance and certification program, and that's also rolling into the Linux Foundation networking compliance and certification program. So with our Snaps.oo, we actually do more than just test, does the API work, but we actually validate what is the behavior behind that API. What happens if I spin up 3 VMs with 5 networks and want to have them all talk to each other, where we kind of have seen that vary depending on how your OpenStack is configured. And the rest of the Kubernetes and Snaps boot is our Linux installer, are available on GitHub, and we're rolling out more and more projects every day. Well, not every day, but seems like every day on GitHub. Last is, in a few hours, I wasn't quite able to get posted before my presentation today, as we've actually been working on an NFV 101 course. So as we've all talked about, how do we bridge that skills gap? We had a member meeting last February, and that was the #1 request, is to do kind of a high-level introductory course. It's 7 chapters, all about 30 minutes long. We have videos and slides available, and eventually it'll also be posted on some other sites as well. But this will just be on the CableLabs blog. We do target some specific cable use cases, but generally everything is fairly broadly applicable across the NFV landscape. So we're hoping this will actually help bridge the gap, especially to get some of the conversations going with product teams, biz dev teams, and not just the engineering teams. So quite pleased that we're getting that launched today, 9 a.m. Mountain. So I'm told it'll be live. So that's my presentation. A couple minutes for questions if there are any.
Well, I actually have a question for you. When I think, like I think many people do, when you think about Kubernetes and OpenStack, I think a lot about VMs and containers, so I'm thinking about compute. We're networking people, so we're probably thinking a lot about networking. And sometimes I think the storage side gets somewhat ignored. I'm wondering if you could share anything, if you have experiences on that side. How are you managing storage and keeping that consistent across the edge? Because I think that's a really important aspect to making this all go.
Yeah, so with the edge in particular, we do see storage get ignored, and a lot of that's for good reason, because typically storage is just needed to load the system, and you're pretty much putting everything you want in memory. So really, if you want to have a firewall or DPI or anything like that, most of the performance is going to be focused on what's in memory and on the compute side. And for things like CDNs, you typically just want local storage because you don't necessarily need that distributed storage because the CDN application itself is going to distribute the storage. We use Ceph as our shared backend. It's open source. It's fairly flexible. It's moderately performant. Though if you really want to get higher performance shared storage, typically you have to go with some kind of a dedicated storage solution, and those can bring new features like automatic deduplication to your stack. But for now, we're focusing a lot more on the data plane and less on the storage side and just providing some basic storage capabilities that will work with the use cases like CDN.
There's time for another question if anyone has one. Oh, here we go. Hang on.
You showed OpenStack and containers, and the fact that you manage the new versions as they are released of these stacks. Any data points or comparison in terms of if one or the other improves the acceptance by the VNFs when you migrate the services underneath? Because one of the typical slowdown points is because VNFs are certified only on one version and not on the next one. So any practical experience of how this improves with some of these technologies?
Yeah, that's one of the things where we're really trying to push and why we're trying to keep fairly current with our version of OpenStack is we really want VNF vendors to start adopting and certifying multiple versions of OpenStack with each VNF version. We do find that it's easier and easier, especially starting with releases about a year and a half ago, like the Okada release of OpenStack, that it really is fairly easy for a VNF to complete integration testing with newer versions. So that's one of the things out there because we can't run these split versions in production and really take advantage of everything. And if you're getting VNFs from 5 or 6 vendors, you really can't have a model where you have 5 or 6 different NFVI implementations out there to support each vendor. So this is where kind of you need to go and work with your supply chain. And when you do those contracts with those VNFs, you need to say, hey, you have to, within X number of months of a version being released, certify on it, and we need to be able to run these on both. Upgrades, especially with OpenStack, can go with no downtime. Typically, you'll have a cluster for your management infrastructure, and those you'll do a rolling upgrade of those. And then for the systems themselves, you just upgrade the individual systems. You don't actually have to reboot the VMs. So on compute nodes, we really only have like 5 or 6 services, or the biggest impactful one when we do upgrades is Open vSwitch or FIDO, whatever you're using for that layer. But the rest of it, KVM's fairly stable. And occasionally you'll do a kernel upgrade, which you'll either reboot the VMs or migrate the VMs to other systems and then replace them. Great question. Definitely something we do look at quite a bit.
Well, thank you, and thanks for the practical advice. We all appreciate that. And I think that with that, we're going to invite our next 2 speakers to come to the stage.